All right, we are good. Hopefully it stays recording. Okay, so what are we doing? Well, we're working with polynomial functions with higher degrees. So we're going to look at the graphs, the end behavior of them, zero polynomial functions, intermediate value theorem. Okay, so when we have something like x, like 4x cubed plus 3x squared minus 7x plus 6, this is a term, this is a term, this is a term. They're separate terms, okay? When it's written in this way, this is standard form. When we go from highest power down to lowest power, the coefficients are the number in front and the leading term, and I think and the leading term, am I on the right one? Yep, I am. Okay, and the leading term is the term of the highest degree term. Okay, all right, so we know that. Graphing them, we've already graphed this one once. Okay, so if it's to the fourth power, our vertex is at 2, 5, 2, 5, compared to negative x to the fourth. We go over 2, up 5, and it goes down like that because of the negative 1 in front. Okay? The y-intercept, to find the y-intercept, you put 0 in for x and you solve. To find the x-intercepts, you set the function equal to 0 and you solve. So the x-intercepts might be some wonky numbers. Okay? So for this one, the x-intercepts, 0 equals negative x minus 2 to the fourth plus 5. If you slide this over, it becomes positive. X minus 2 to the fourth plus equals 5. Take the fourth root of each side. The fourth root of 5 is some decimal number. And then you take 2 to the other side, but you have a plus or minus. So x equals 2 plus or minus the fourth root of 5. So it's going to be, and this is like 1.3-ish. So it's going to be 3.3 and 0.7-ish about. Okay, end behavior. This is something that is important to know. Okay, so if your leading coefficient is positive, it will end up. It'll end going up. And since it's a cubic, since it's an odd powered function, its start will be in the opposite place that its end is at. So if it ends up, it starts down. Starts down, ends up. Now, if the leading coefficient is negative, it'll start up and go down. Okay, it'll end going down. Quartic is fourth power. Okay, so it's an even power. If the first term coefficient is positive, it'll end going up, so it'll start from up. It's up, up. If its leading coefficient is negative, it'll end going down, so it'll start from down, down, down. Okay? If you have a fifth power, they'll look like this. That's where the leading coefficient is positive. This is where the leading coefficient is negative. See how the pattern that develops? If it's odd power, then they're opposite. They start and end opposite. They're even power, they start and end the same. Okay, kind of like a parabola does. All right. If you have x to the sixth power, you have 6 zeros. If you have x to the fifth power, you'll have 5 zeros. Unless some of the zeros are imaginary. So here's a 6th power problem. You have, these are imaginary zeros because they don't hit the x-axis. So this one would only have 2 zeros because it only crosses the x-axis twice. These other humps, if they would cross the x-axis, then we'd have more intercepts. So there's at most 6 zeros, and at most in a 5th term, 5 zeros, okay? But you might have some imaginary roots, and if you have imaginary roots, that takes away zeros, okay? That takes away zeros. All right, so this function will have 3 zeros, okay? It'll end going towards infinity, and it'll start going towards negative infinity. So this has a leading coefficient that's positive, and it's an odd power, okay? So that's what it looks like, okay? This one, if it has a negative, it'll end going, as x goes towards positive infinity, the y goes towards negative infinity, so it'll end up going down. As you go towards negative infinity, it'll go towards positive infinity, so you'll start going up. And then it'll have 1, 2, 3 zeros. It'll either have 3 zeros or 1 zero, okay? Because if it humps like this, then it'll only have 1 zero, okay? So 4th term, it'll look like that. All right, end behavior of this. So you can look at this equation, 4th degree polynomial, okay? So if it's 4th degree, will it end going up or down? Up, because it's positive here. So it'll end going up, so it'll make a W of some sort, okay? It makes a W. So it says, describe it using limits. Well, the limit as x approaches negative infinity will be infinity, because as you're going this way infinitely, it'll be going up. The limit as x approaches infinity will be infinity, because going this way, it'll keep going up, okay? All right. Finding the zeros of a polynomial function is where the graph crosses the x-axis, okay? So you could graph it and find the zeros that way. You could factor it. So x equals 0, 3, and negative 1 by factoring. Okay? The multiplicity of a function, okay? If we have x minus 2 squared times x plus 5 cubed times x squared, the roots are 0, 2, and negative 5. This has a multiplicity of 2 because of its power. This is a multiplicity of 2 because it's the second power. This would have a multiplicity of 3 because of the third power. Okay? So, if it has a multiplicity of 2 on a graph, it bounces there. If it has a multiplicity of an odd number, it crosses the graph. So, negative 5 is over here, 0 is here, 2 is here. So, this is a 7th power function. So, what's going to happen is it's going to go up like this. It's going to flatten out, but cross at negative 5. Then it'll go down and bounce at 0 because it has a multiplicity of 2. So, if it has a multiplicity of 2 or 4 or 6 or 8, it's going to bounce on the x-axis. It's not going to cross it. It's going to bounce. And then again at 2, it has a multiplicity of 2, so it's going to bounce. So the function x minus 2 squared, x plus 5 cubed would look like this. Okay? If you graph it on your graphing calculator, it may not be exactly the same, but it'll look similar to that. Even multiplicity, we talked about that. The graph of this, -2 and 1, okay, are our roots. So here's 1, here's -2. If it's to the third power, it'll cross. If it's to the second power, it's going to bounce. All right, so what's the total powers here? 5, and the first term coefficient is positive, so it's going to end up. So at 1, we said it's going to bounce, so it's going to go like that and bounce. And then at 2, it's going to cross. So the graph would look like that. And theirs is fairly similar to mine. Intermediate value theorem says, well, if this is negative and this is positive, then there must be a 0 somewhere in between the negative number and the positive number. That's what the intermediate value theorem is. And we'll talk about it at length in calculus, but that's basically what it means. Is if you have like 6, -1, and 8, 1, somewhere in between 6 and 8, there has to be a 0. Okay, because the graph has to cross to get from -1 to 1. Okay, that's the intermediate value theorem. All right, so that's it for that part of it. Now, what are we going to see on our homework problems? Lots of graphing today. Okay, so the graph of 5 times x minus 4 to the third. Okay, so x to the third is translated where? What's the -4 do to it? Moves it where? Right 4. So x cubed, the original graph is like this. The original graph is like this, and I think they'll maybe have you graph both of them. I don't remember. So you'll go to the right 4, and then what does the 5 do to it? Makes it 5 times, stretches it 5 times in the y direction, makes it 5 times skinnier and taller. Okay, so the graph is translated 4 units to the right and stretched vertically by a factor of 5. And then the y-intercept of this one is when you put in a 0 for x, 5 times 0 minus 4 cubed, which is 5 times -4 cubed, or 5 times 64 negative, which is -320. The y-intercept is 0, -320. Okay? Take a while to get down to there on the graph. Okay. All right. -2x to the fourth plus 1. Well, see, what does it want? So, I don't know if they're going from x to the fourth. I assume they're going from the original x to the fourth graph when they describe this. So you're horizontally shifting this graph, how much, what way? 1 unit to the left. And then, after you shift it 1 unit to the left, you're going to vertically shrink it, or vertically stretch it by 2. And then you're going to reflect it across the x-axis. It's going to flip upside down. And finally, we're going to take a vertical shift up 1 unit up. Okay. So what's a y-intercept? Well, again, you put a 0 in, you get 1. 1 to the fourth power is 1. times negative 2 is negative 2 plus 1 is negative 1. So the ordered pair is 0, negative 1. So you have something like that. Then you'll have to match graphs. Now the matching graphs is really easy if you understand end behavior. This first one, odd power, negative first term coefficient, so it's going to end down and it's going to start up. So it's D. This one goes to D. This one, odd power, going to go down. This one actually is this one because there's less humps in it. A fifth has an extra hump in it versus a third power. Fifth power is going to be D. Odd power going to end down. Okay. Fifth power ending up is this one. Third power ending up is this one. See how there's less humps in this versus this and this? The more powers you have, the more humps you'll have in it. Okay. Yeah, and then you'll have to answer questions below that. So find the y-intercept, put 0 in for x. This one is a good one. This one crosses at negative 4, crosses at 0, and crosses at 4. Okay? So if it crosses, there's one power there. So it can't be a squared, or a squared, because squareds bounce. Okay? So it has a negative coefficient, so you could have negative 0, but then what happens here is this one is also a negative, and negative times a negative is a positive, so x would be positive here, so that's why it can't be that one, and it has to be that one. Okay, so that one's kind of the same as the last, and you're doing end behavior on this one. What's the end behavior? Well, as you go, it's negative. And if it's to the fourth power, it'll start down and end down. Start down and end down. So as you go towards infinity, it'll go towards negative infinity. And as you go towards negative infinity, it'll be negative infinity. Because n equals the fourth, and the leading coefficient is negative 5. Even, odd. Yeah. So you got to be careful how you fill those out, because the last two, that was a negative infinity, 4, that. It's got to, everything's got to fit in there. So I'll put that out for you. And then we'll spend a little more time on it on Monday. We do not, or Tuesday, we do not have this class on Thursday next week because parent teacher conferences. We have it on Friday. So Friday will be a B day. Friday will be a B day next week. Who's your study table teacher? Yeah, they'll fix it.